Welcome to the new era of video creation with VAEs 8. Today we will discuss with the image generation. Here are the contents. Over the past decade, artificial intelligence has revolutionized the creative industries, especially in the field of image generation. AI models like GANs, Generative Adversarial Networks, VAEs, Variational Autoencoders, and more recently, diffusion models, have transformed the way we think about creativity, allowing machines to generate high-quality images from nothing but algorithms and training data. These technologies are not only capable of generating realistic images, but can also perform tasks like image manipulation, enhancement, and style transfer, offering new possibilities for artists, designers, and content creators. The development of these tools is pushing the boundaries of what's possible in creative fields, where machines can now assist or even autonomously produce art, designs, and other visual content. AI-generated images are becoming increasingly indistinguishable from human-created ones, opening up a range of applications in entertainment, advertising, and even personalized digital content. Image generation with AI has a rich history, evolving from simple image manipulation to creating photorealistic images from scratch. Initially, image synthesis involved basic transformations like applying filters or manually combining parts of images to create new compositions. Early techniques were often limited in their ability to generate truly novel or realistic images. With the advent of Generative Adversarial Networks, GANs, in 2014, a major breakthrough occurred. GANs introduced a powerful framework that enabled the generation of realistic images through a competitive process between two neural networks, the generator and the discriminator. Since then, the field has expanded rapidly, and today's models are capable of generating incredibly detailed and high-resolution images, with much more control over the creative process. Researchers are now using these models to create not only static images, but also dynamic, evolving content, all with the goal of pushing the boundaries of AI's creative potential. Several key technologies are driving the progress in AI-driven image generation. The most notable are Generative Adversarial Networks, GANs, which consist of two neural networks, the generator and the discriminator, that compete against each other to create realistic images. GANs have become the cornerstone of image generation and have led to advances in everything from creating realistic faces to generating entire scenes. Variational Autoencoders, VAEs, are another important technology. Unlike GANs, VAEs aim to map data into a latent space and then sample from that space to generate new images. While they do not always produce images as high quality as GANs, VAEs offer a more structured approach to generating images and can be used for tasks like image interpolation and style transfer. More recently, diffusion models have emerged as a powerful tool for image generation. These models work by gradually denoising a random pattern of noise to transform it into a coherent image, offering a fresh perspective on image generation. Neural style transfer is another key technique, which involves modifying an image to match the artistic style of another, combining content from one image with the style of another. These technologies have collectively advanced the ability of AI to create compelling, high-quality images across a variety of domains. In recent years, GAN-based models have seen a number of advancements that have improved their ability to generate high-quality, high-resolution images. One such development is progressive growing of GANs, PGGN, which trains GANs on low-resolution images initially and then progressively increases the resolution as training continues. This technique improves stability during training and allows the model to generate much higher quality images without encountering issues like mode collapse or instability, which were common in earlier GANs. Another major improvement is conditional GANs, CGANs, which allow the model to generate images based on specific conditions or inputs, such as creating an image from a textual description, altering the appearance of an object, or even generating images based on specific attributes. This approach has significantly broadened the scope of tasks GANs can perform. The introduction of Style GAN revolutionized image generation, particularly in the creation of human faces. Style GAN models can generate hyper-realistic images of people who do not exist, with incredibly fine details and diversity in facial features, expressions, and backgrounds. Style GAN has also been adapted for various tasks such as creating high-quality art, generating diverse characters for video games, and designing avatars for virtual worlds. Diffusion models have recently emerged as a powerful alternative to GANs in image generation. These models work by introducing random noise to an image and then gradually removing that noise through a process called denoising to create a coherent image. This gradual transformation allows the model to produce highly detailed and accurate images with more natural structures. What sets diffusion models apart is their ability to generate diverse and high-quality images, even when trained on relatively limited data. The denoising process ensures that the model doesn't overfit to the training data, but instead produces varied outputs that can still reflect the diversity of the real world. Additionally, the training process for diffusion models is relatively stable compared to GANs, which can sometimes suffer from issues like mode collapse. One of the significant advantages of diffusion models is their ability to generate high-resolution images. Unlike some GAN-based models, diffusion models excel at generating larger images with fine detail, making them particularly useful in fields like digital art, 3D rendering, and medical imaging, where high quality is crucial. While GANs often steal the spotlight in image generation, variational autoencoders, VAEs, are also a key player in the field. VAEs offer a probabilistic approach to image generation by learning a latent space, where each point represents a set of possible images. By sampling from this latent space, a VAE can generate entirely new images that share certain characteristics with the original training data. One of the strengths of VAEs is their ability to manipulate this latent space in creative ways. For example, you can interpolate between images by moving smoothly through the latent space, effectively generating new images that blend elements from multiple sources. This makes VAEs particularly useful for tasks such as morphing between two faces or generating a sequence of images that smoothly transition from one state to another. However, VAEs typically do not produce images with the same level of photorealism as GANs, especially when generating high-resolution images. They tend to generate slightly blurrier images due to their probabilistic nature, but they offer more control and stability during training. Neural style transfer is a popular technique that allows us to blend the content of one image with the artistic style of another. This has led to many creative applications, including generating artwork that combines the visual elements of a photo with the style of famous artists like Van Gogh or Picasso. Neural style transfer works by using deep neural networks to optimize the content image to match the texture, color palette, and brush strokes of the style image. Recent advances have allowed for more detailed and complex style transfers. For example, researchers have developed techniques to preserve fine details while still applying artistic styles, resulting in images that retain the structure and content of the original, while showcasing the style of another piece of art. In addition to static images, style transfer is also being applied to video and animation, allowing entire video sequences to be transformed in the style of a given artist, creating immersive animated experiences.
Real-time image generation is a growing area of interest, particularly in fields like gaming, VR/AR, and interactive media, where users expect near-instantaneous responses to their inputs. AI models have been optimized for speed to generate high-quality images in real time. One of the significant challenges in this area is balancing speed and quality. Traditional image generation models often require a significant amount of time and computational resources to produce high-resolution images. Recent innovations in hardware, including more powerful GPUs and cloud-based processing, have made it possible to train and deploy AI models that can generate images in real time. Neural networks are now being specifically designed to optimize for both speed and quality, reducing the time it takes to create realistic images. This is particularly useful in interactive applications like gaming, where players expect to see complex visual effects and environments generated seamlessly and dynamically as they interact with the virtual world. AI is not just transforming how images are generated, but also how art is created and experienced. Digital artists are increasingly turning to AI tools to help in the creative process, whether it's for generating ideas, creating complex compositions, or enhancing their work. AI models are capable of producing images based on a prompt, allowing artists to quickly visualize concepts or generate new styles and effects that they might not have thought of otherwise. AI-generated art has become a significant form of creative expression in its own right, with AI artists producing works that are sold at galleries and auction houses. Some argue that AI art represents a new frontier in creative possibilities, while others raise ethical concerns, questioning the ownership and authenticity of AI-generated art. As AI continues to evolve in this space, the boundaries between human and machine-generated creativity are becoming increasingly blurred. AI-driven image generation is having a profound impact on the healthcare industry, particularly in medical imaging. AI models can be trained to generate or enhance medical images, such as CT scans, MRIs, and X-rays, to improve diagnostic accuracy. These models can detect patterns that may be difficult for the human eye to discern, such as early signs of tumors, lesions, or other anomalies. In addition to analysis, AI-generated images are used to create high-quality simulated images for training healthcare professionals. This allows medical students to study rare conditions and learn diagnostic procedures without needing to rely on actual patient data. Moreover, AI-generated images are also being used in patient education, helping patients visualize their conditions or potential treatment options in a more understandable and personalized way.
Speaker notes. As with all powerful technologies, AI-generated images raise a range of ethical concerns. One of the most significant issues is the question of authorship and copyright. If an AI generates an image, who owns the rights to that image? The developer of the AI, the user who input the data, or the creator of the training data? These questions are still being debated, and there's a growing need for legal frameworks to address the ownership of AI-generated content. Another concern is the potential for misuse. AI can be used to create highly realistic images that could be used to deceive or manipulate people. This includes deepfakes, where AI-generated images or videos are made to portray people doing or saying things they never did. The spread of misleading or harmful images online is a growing problem. Additionally, bias in training data can lead to biased image generation. If the training data reflects societal biases, these biases can be amplified in the generated images. This issue has led to efforts to ensure more diverse and representative datasets in order to reduce the risk of biased outputs. Finally, transparency is key in AI-generated content. As AI becomes more integrated into the creative industries, it is essential that users and viewers are aware when content is AI-generated. This can help manage expectations and avoid the confusion that might arise from thinking an image was created by a human when it was actually created by a machine. Looking forward, the future of AI image generation seems incredibly exciting. We can expect even more photorealistic images and enhanced creative control, with AI models becoming more intuitive and responsive to user inputs. AI will increasingly play a role in collaborative creative processes, working alongside artists, designers, and content creators to produce new forms of art and design that blend human creativity with machine-generated content. We are also likely to see the development of more robust ethical frameworks to address issues related to authorship, bias, and misuse. As AI continues to evolve, these frameworks will become critical in ensuring that AI-generated images are used responsibly and ethically. In the coming years, AI image generation will continue to push the boundaries of what's possible in digital art, design, and other industries, creating new opportunities and challenges that we can only begin to imagine.